All right. What's up? I am at Nando's because I'm hungry. I'm about to get some Portuguese chicken. While I'm waiting for that, I figured this is a good time for me to talk to you about proxies and load balancers. So last time we talked, I shared everything I knew about routers and switches. Well, not everything, but everything you need to know for the test. And now we want to talk about load balancers first. What is a load balancer? It's really a device that's there. It's designed to ensure business continuity. It's all about maximizing availability and scalability. And it does this by leveraging a collection of identical servers, which are known as a load balanced cluster. So I know that's a bunch of big words there. Let me break it down for you. By availability, I'm just referring to, just making sure that a resource is there when you need it. And by scalability, I'm referring to the idea that a business system the performance of a system shouldn't degrade as it services more clients, right? So it stays the same. And the way you can do that is by either scaling up or scaling out. Scaling up refers to adding more RAM or hard drive space or a different kind of hard drive like a solid state drive or a faster processor. And scaling out refers to adding an additional server to the load balance cluster. Those are two ways that you can maximize the availability of a system. Now, the interesting thing about load balancers is that they're all over the place. Whenever you go to Google, you're not actually going to one web server. You're actually hitting a load balancer, which is the front end for a load balance cluster. And you don't realize it, though, because it happens seamlessly. And the load balancer can use various algorithms to ensure that the availability of the resource is maximized. Some of them could just be round robin. It can just say, all right, first come, first serve. The first request comes in to the load balancer, and it just sends it to the first server in the load balance cluster. The second request comes in, it goes to the second server in the load balance cluster, so on and so forth. Or you can use a connection-based algorithm. So it might say, all right, this server is configured to allow a maximum of 1,000 incoming connections within a 5-minute time period. If that threshold is exceeded, then this server in the cluster is out of operation, and you need to use server 2 instead. That's another way you can do it. You can also vary the algorithm based on utilization. So perhaps, server 2 is spiked. The CPU is pegged at 100%, but server 3, it's only at 20% utilization. That might be a good candidate in the load balancing algorithm to be the next server to service the client request. Now, there are actually two kinds of load balancers. There's hardware and software. Hardware is the most common. It's the kind that you're probably the most familiar with if you've ever seen one. Usually these things sit in a network security rack somewhere in a data closet. But software is also, an option. In that situation, you would just install the load balancing software on each server in the load balanced cluster. And then it will be responsible for, distributing the load and managing it that way. Now, of course, load balancers are really good, but they do present some security considerations, some security risks. Well, challenges, I guess you would say. For one, you have now a cluster of servers on the back end that are all running the same software and the same configuration. And therefore, you need to make sure they're all running at the same patch level. You need to make sure that they're all maintained and they're not vulnerable to anything. And additionally, you need to make sure the load balancer itself is properly patched and configured, because you wouldn't want an attacker exploiting some vulnerability in a load balancer and then taking it out of operation, effectively denying service to legitimate clients, which could be extremely cost prohibitive for a business that relies on the internet for its online presence and for revenue. So definitely keep those things in mind for load balancers. When it comes to proxies, a proxy is really it's a device sitting between a user on a local area network and the internet. And it forwards the request on behalf of the client. And so, for example, you might go to google.com, the proxy receives the request, and then it will re-originate the request to the server. When the server replies, it goes to the proxy, and then the proxy forwards it to the client. Now, you might say that sounds kind of inefficient. Why would you do it? There's actually two reasons. One is for performance, the opposite of inefficiency, and the second is for policy enforcement. So from the performance perspective, it can really improve performance because it can cache. That is, it can store the response from the server in a temporary location on disk or in RAM, so that subsequent requests for that same resource don't have to go out to the internet. It reduces latency. Because you don't have to make another request out to the internet, you can just pull it directly from the proxy. And of course, this cache is updated on a regular basis. and also saves bandwidth as well, which can also save costs. Another reason, like I mentioned, is for policy enforcement. This is where you have the proxy doing maybe URL filtering or content filtering, where it has a database of URLs, it scours the internet, and users can subscribe to this database, and the content is then categorized based on whatever it is. Maybe it's gambling, or it is swimsuit models or something like that. They're categorized and then they're blocked. So if I try to access a web resource that's in the gambling category, it would automatically be blocked, and I wouldn't be able to go there. Usually the company would send like a web page that shows a reminder of that company's policies and procedures and a reminder that their content's being logged. That's all I have right now. I think my chicken is actually ready. Just go ahead and scroll down, and your homework right now is to go to Google, find some load balancers and some content filters, some proxies, and let me know the prices of those things. Leave the manufacturer's name and the prices down below. You might be really surprised at how much these things cost. And make sure you, of course, thumb this video up and subscribe, because everyone loves subscribers. And next time we meet tomorrow at 8 a.m. Eastern, 7 a.m. Central, we're going to talk about web. We're actually going to talk about, what are we talking about? We're talking about VPN concentrators and web gateways, web security gateways, man. When I'm hungry, I can't really think well. So I'm about to dig into this chicken. I will see you guys tomorrow morning. Bye.